All right, tonight you're going to take notes a little bit differently. We're going to make a flip book. You should already have the theorem on the front page of your flip book. The theorem says that the measure of a central angle is equal to the measure of its intercepted arc. All right, and this is the picture. Notice this is a central angle because the central angle has the vertex at the center. All right, and you should already have the picture on your flip book. What I would like for you to write under the first flap is that the measure of the angle equals the arc. Here's an example. I would also like for you to put this example underneath the flap. So you might want to press pause right here and draw this picture. What I want you to do is be able to find the measure of arc NP. So remember, NP goes from here to here. Now this 30 is a little bit deceiving because the 30 should actually go here. That's what this arrow means. So arc NP does not equal 30, but we need to find it. Now remember, from M to N is going to be 70 because its central angle is 70. And from P to Q is going to be 30 because its central angle equals 30. Right here is the diameter because it goes through the center. I know that that gives me 180 degrees. So in order to find NP, I can say 70 plus some number plus 30 has to equal 180 because that's a semicircle. If I combine my like terms, 70 plus 30 is 100. So 100 plus what number is going to equal 180? So NP would have to equal 80 because 100 plus 80 is going to equal 180. So NP is going to equal 80. And I've answered the question. The measure of NP equals 80. Now close the first flap and let's go to the second flap. You should find this theorem on the second flap, and this is the theorem that we talked about Monday. The measure of an inscribed angle is equal to half the measure of its intercepted arc. I know this is an inscribed angle because the vertex of that angle is on the circle, different from a central angle. And the arc is not equal any longer, it's equal to half the arc. So what I would like for you to do is open that first flap and copy this formula. This is the formula. This is what the theorem is telling you, that the angle is equal to half the arc measure. So you might want to press pause and write this formula down underneath the second flap. Here's an example. The question wants us to find the measure of angle A. If I look at the picture, I notice that angle A is an inscribed angle because the vertex is on the circle instead of the center. In this picture, I notice that the central angle is already given. You're given the measure. That's a central angle because that's the center. So that makes this arc equal to 132. So if I use the formula, the measure of angle A is going to be equal to half of the intercepted arc, which would be half of 132. You might need a calculator here. Half of 132 is 66. Now let's go to the third flap. This is what we're going to be working on tomorrow in class. It says that an angle formed by two chords. Now remember, the chords are just segments that are inside a circle. Intersecting inside the circle, keyword is inside, is equal to half of the sum. Remember, sum tells you to add the intercepted arcs. So your picture, which is also on the front flap, you have two chords. These are chords. Notice they intersect inside your circle. All right. So underneath the third flap, what I want you to do is write this formula, which is telling you what this theorem is explaining. The angle is equal to half the sum of the arcs. You must add your two arcs. that the two angles or vertical angles form. Alright? Now on this one we're going to have two examples, so make sure you leave room underneath the third flap to draw two examples. Here's your first example. First, let's find angle 1. Angle 1 is formed here. Notice, angle 1 intercepts the arc that measures 131. Angle 1 is going to be equal to its vertical angle. So the vertical angle is going to be here. And it intercepts the arc that measures 33 degrees. So if I use the formula to find angle 1, I'm going to say angle 1 is equal to half of the sum of the two intercepted arcs. So one arc is 33 and the other arc is 131. Now if I work this correctly, following the order of operations, I need to work my parentheses first. So 33 plus 131 is going to give me 164. That stays inside the parentheses. So I need to take half of 164 to determine the measure of angle 1. And half of 164 is going to give me 82. So I know that angle 1 is going to equal 82 degrees. Now this question also wants me to find angle 2. And if I notice, angle 1 and angle 2 combined form a semicircle. So that means they're supplementary, they're linear pairs. So if I want to find the measure of angle 1 or angle 2, I know that if I add angle 1 plus whatever angle 2 equals, they have to equal 180 degrees. So to solve that, the easiest way is going to be to subtract 82 from both sides. So that's going to tell me that angle 2 is going to have to equal 98 degrees. And you can check that by adding 98 and 82. And they should give you a total of 180. If it doesn't, you've done something wrong. Make sure you leave room underneath this to put another example. On this one, this time it's a little bit different because I've given you, again we have two chords. I've given you the measure of this angle is 115. I know that it's going to be congruent to its vertical angle, which is going to be here. The arc that is intercepted by the 150 degree angle is here. And the arc that goes with the other vertical angle is 105. So what I've got to do is I've got to work this out. I know that the angle, which is 115 degrees, is equal to half of the sum, which is 105, plus x. Now there's different ways to do it. To me, it's easier to go ahead and get rid of your fraction. So what I'm going to do is I'm going to multiply both sides by 2. So that gives me 230. The 1/2 and the 2 cancel each other out because half of 2 is 1 equals 105 plus x. So to solve for x, what I need to do is isolate the x, so I'm going to subtract 105 from both sides. So the remaining arc measure is going to be 125. So those are the two examples of when you have intersecting chords. You want to close that flap and let's open the fourth flap. And this theorem is talking about angles formed by two secants. Remember, a secant is a line that goes outside the circle. Or you could have two tangents. Or you could have a secant and a tangent. But the main thing is that they intersect outside the circle. And it's equal to half the difference. The difference is telling you to subtract. So underneath the fourth flap, what I want you to do is I want you to write this formula. Again, we have 2 examples, so please leave room underneath the flap to put both examples on your notes. Here's the first example. Notice I have 2 secants because the lines go outside the circle. And these secants intersect outside the circle. So I need to use the formula. It tells me that the angle, which I don't know, it's angle 1, is equal to half the difference. And you want to subtract the larger angle first. So I'm going to say 80 subtract 32. So if I follow the order of operations, remember I have to do the parentheses first. So to find angle 1, I know that's going to be half. 80 minus 32 is going to be 48. And I know that half of 48, if I take my calculator and divide by 2, is going to give me 24. So angle 1 is equal to 24, and it looks like an acute angle, so that's a good answer. Make sure you left room for the second example here. Here's the second example. Again, it's a little different because I still have a tangent instead of 2 secants. This is my tangent because it only intersects once. And this is my secant. They do intersect outside the circle, so I'm going to follow the same rule. I know that the angle, which is 38 degrees in this case, is equal to half the difference of the 2 arcs. The larger arc is 180, and I want to subtract the smaller arc, which is x. Again, to me, it's easier if you get rid of the fraction first. So to get rid of the 1/2, I'm going to multiply both sides by 2. Half of 2 is 1, so those cancel. 38 times 2 is 76, equals 180. Subtract x. And if I solve for x, I need to subtract both sides, 180 from both sides. Now here's going to be a little freaky because you're going to get a negative number, but that's okay. Alright, so 76 minus 180 is going to be negative 104. But that equals negative x. So if I divide both sides by negative 1, I come up with my positive number. Positive 104 equals x. So that would be the value of my minor arc inside. And that's the lesson here. Make sure you bring your flip book tomorrow to class so we can use these formulas to help us work the problems.